Okay, we're going to make box and whisker plots. Sounds a lot more fun than it is, right? No, it's actually pretty fun to do a box and whisker plot. So what you're going to do is you're going to take your data, which this isn't the best. You're going to take your data and you're going to graph it. It's another way for us to organize our data. Remember we organized it in a stem and leaf plot before? This is a box and whisker. So what you're going to need to find is a series of things. So first, you need to get your number line. How did I know how to increment it? It's entirely up to you. The smallest value is 44, and the largest value is 1,194. So you knew your number line was going to have to vary. Otherwise, it would be super, super long. Okay. Next step is you're going to find the median of the numbers. Once you find the medians, you have to find the extreme values. So basically what you're doing is you're finding 5 points, okay? These are your 5 points that you need to find. Remember in the previous lesson, I taught you how to find, to split it into 4 quarters for the IQR. So that's where you took your data and you found your center number. Then you found the median of the lower half, which is called your lower quartile right here. And then you found the median of your upper half, which is called your upper quartile. These values, your upper and lower extremes, were your smallest and greatest value. So your least and greatest value. Then you plot those points. Now, here's the problem. When you make it on a number line, you don't exactly know where those numbers are falling because you don't normally put these numbers on your box and whisker plot. So this is just a way for us to organize our data and interpret it, not necessarily use it for exact points. Because once you do this, you're going to draw it. Notice the numbers went away. So what's important here is what the box and the whiskers look like. So remember, this was our median, this was our lower quartile, this was our lower extreme, this was our upper quartile, and this was our upper extreme. The median has the line that goes down through the center. So I want you to notice a couple of things. First, I want you to notice the spread of the box. It's pretty wide. That means the data is pretty far apart, even in the center part of your data. I want you to notice your whiskers. That means from the median of your lower quartile to your lowest value is pretty close together. And same with the upper quartile and the upper extreme. They're pretty close together. Notice the median doesn't fall directly in the center of the box. That means the median isn't directly in the center because most of your data is higher. So the middle number is not the middle number of numbers going from incrementing 1, 2, 3, 4, 5, 6, 7. It's numbers that are all over the place, if you remember the data we were looking at. So your median isn't going to be necessarily in the center of your box. So again, a couple things to pay attention to. This is a very large box, rectangle, which means our data is very spread out. The median is not in the center. There's more upper numbers than there are lower numbers. And the whiskers aren't too long, so my extreme values aren't too far from my normal data. That's really what you have to be able to do is interpret a box and whisker. Okay, so it's easier here. Let's start by putting the numbers in order. So once I can do that, I can show you that step 1, you have to find 5 points. Okay? You have to find the lower extreme, which is the smallest number. You have to find the lower quartile, the median, the upper quartile, and the upper extreme. That's everything that you need to find. So here we go. So we have 4, 7, 9. So I want to use them. Let's see. Looks like 14, 15. Notice I'm writing them underneath so I can keep track of that I'm not missing any. 18 is twice. Then I have 22, 26, 32, and 45. Whew. So I want to find my 5 points right away. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. That means there's only one in the middle. And take 1 away from 11 is 10. Divide 10 in half. So the fifth number, 1, 2, 3, 4, 5. Here's your median. Box that in. That's your first point. Okay? Then I need to find my lower quartile, which is the middle. So right here, that's your lower quartile, and then your upper quartile. And then these are your extremes, right there and right there. So now when I make my number line, I gotta remember I gotta go from 4 to 45. So it's up to you how you make your number line. You can go by 5s if you want. You can go by 2s if you want. I'm thinking 5s probably would be good. So if I went 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay? So usually you can make the box and whisker above or below. It doesn't matter, above or below. So I have a point right here at 45. And then this is 30. So 26 is going to be about right here. And then 18 will be about right here. See how it's just about? 5, 9 will be about right here. Oh, I forgot 18, didn't I? 10, 15, 20. Oh, I'm sorry, I forgot 4. And 4 would be about right here. Okay? So, first thing you want to do is make your box. Remember, these are your whiskers. Actually, let's make our whiskers first. Your whiskers go 1 out. So from 45 to 26, right here. That's a long whisker. And then here's your box. It goes from the lower quartile to the upper quartile. So from 9 to 26, like that. And then here's your median right there. So what can you tell me about this? Well, the box isn't as long, so the data isn't as varied. And you can look at the data and see it's not as varied. Although it has one long whisker. Well, it has a long whisker because the distance from 32 to 45 is pretty big based on how I incremented my number line. Notice the box, the median is not directly in the center, and there's more variance on the lower half than in the upper half. The upper half tends to be the numbers are closer together. And there you go. So again, 5 points. Lower extreme, lowest value. Upper extreme, highest value. Median first. Then split it in half for the lower quartile and the upper quartile. I'm going to erase this and show you their perfected one. There it is. They went by tens. Notice their box looks a little bit closer together. It's a little squeezed together more because of their number line. So, what is the smallest percent of sunny days in any state? So these are sunny days per year. So what's the smallest percent? Well, that's looking right here. So it's probably about what? About 23%. So you can only educate guests on a box and whisker. If you don't have the data in front of you, you can only educate guests. Next question. Half of the selective cities have an average of what? Okay. Remember when we were doing the IQR, we split it into 4 sections. This is split into 4 sections, 4 equal sections. This is worth 25% of your data. This is 25% of your data. This is 25% of your data. And this is 25% of your data. It doesn't look like it because your number line isn't your exact numbers. So it's very hard for you to comprehend that, but please understand each one of these represent 25%. So half of the selective cities have an average of what? So you have to look here, makes half of your data, right? So what about 56%? That's half of your data. What does the length of the box and the box and whisker plot tell about the data? Well, if you look at it, it's very, very close together. So your data is very close between 56 and say 62 days of sunny days, I should say. Whereas from here to here, your whiskers are really long, meaning you had some outlier days. You had some percent of days that weren't sunny, really, really low, and percent of days in some states that were always sunny. Whereas this is the average group fell in this category, and they're really close together. Somewhere between 51 and 62 sunny days. What is the smallest amount per month spent on clothing? So you're going to guess this one. Half the monthly expenditures on clothes were under what amount? So remember, half is median this way. It's $80. What does the length of the box tell us? It tells you the data is pretty close, very spread out. Goes from here all the way over here. They want the box. Deciduous trees versus evergreen trees. Look at that. There's an evergreen tree that didn't grow very tall, did it? All by itself over here. So the first question would be, most evergreen trees are taller than the deciduous trees, right? Most evergreens fall over here in the higher height, and most deciduous fall in the lower half. Compact cars versus sedan cars. Most compact cars, if you look at it, have a higher gas mileage than sedan cars do. These take up more gas, and you can't go as far. And that's a box and whisker.